Okay, we'll continue with our discussion. So we are going to practically see how thermal noise is present in the MOSFETs. So we have modeled the thermal noise using equation. We have found the RMS voltage and current, but practically how this thermal noise available in the devices, whatever we are going to study. So we are more bothered about MOSFET and FET. So we are not going to study about anything with respect to BJT. So we have a drain current noise in MOSFET which is going to follow this thermal noise model. So you know MOSFET or FET is a family of field effect transistors are all voltage controlled devices. So definitely you know the input resistance of a MOSFET is gate. Gate side is infinity. So it is almost open, right? So infinite resistance will contribute to infinite noise as per our theory. You know that we have seen that the noise voltage is KTR delta F. Resistance value is very large. Then the noise power is also going to be very large. So in MOSFET or the family of field effect transistors, this thermal noise will naturally be there and it is present in the form of drain current noise. So you know you will have a conductive channel in effect and a drain current will flow through that, and that drain current will have some component of thermal noise. And the formula you see it is 4 kT gamma GD naught into delta F. So you can recollect the formula what we have seen for current. It is 4 kT G into delta F. So the drain current and noise also follow the same pattern. You can see here 4 kT. Instead of G, you have gamma GD naught into delta F. So this GD naught, you know, in MOSFET, we have this conductance. So the drain conductance you have at 0 VDS, and gamma is a parameter, which is a device parameter, and the value of gamma is 1 when the VDS is 0, and it will slow down to 2 by 3 in saturation. So you can relate now how the drain current in MOSFET is also going to take the same equation as the thermal noise current equation for a resistance. So you know MOSFET is a voltage controlled resistance. So definitely whatever thermal noise formula applicable for resistors, you can use the same thing for MOSFETs also. So that is one proof saying this equation is relevant to whatever general equation we have seen for thermal noise in